All right, so to determine what kind of parallelogram this is, given the points, you can use the distance formula to find the length of all of these sides and then the diagonal. So since this looks like a rectangle, you can use the distance formula to measure each of the diagonals, so EU and TN. Notice that they are both square root 125, square root 125, so they are congruent, which means that they they're congruent, so that means it has to be a rectangle or a square. So you can also use Desmos graphing to look at these. So we have 4 different ways to show a quadrilateral is a parallelogram in the coordinate plane. We would have to check to see for a pair of opposite sides that are congruent and parallel. Same thing here. So you've got a couple of examples to look through. We're going to jump right to here. All right, so determine what type of quadrilateral EFGH is given the following points. So one way to do this in the Desmos scientific calculator, we're going to take this. Put this here. So what I'm going to do is do the distance formula without the radical because that'll round it for me anyway. So either way, it doesn't matter. So distance formula is x1 minus x2 squared plus y1 minus y2 squared. So for EF, I'm going to take 5 minus 11 squared and then plus -1 minus -3 squared. I'm actually going to copy this whole formula for the next one. So FG. So then I have 11 minus 5 and -3 minus -5. It's -5. 44. Copy and paste it for GH. So then I have 5 minus -1 and -5 minus -3. 5 minus -1, -5 minus -3. All right. Ooh, that's supposed to be squared. That's why. There we go. And then last one, EH, is 5 minus -1 and -1 minus -3. So all sides are equal. And then I'm going to do the diagonals. So EG, so I get 5 minus 5 and -1 minus -5. And then FH is 11. Oops. Minus -1 and -3 minus -3. All right, so all 4 sides are equal, 40, 40, 40, 40, and my diagonals are not. So all 4 sides being equal has to be a square or a rhombus. And then squares have diagonals that are equal, rhombus does not. So this makes that a rhombus. All right, and then you can also use Desmos graphing calculator. And we'll type each of these points in. So we have negative 2, 4. We can label that A. And negative 1, 2. We can label that B. Negative 3, 1. We can label this C. And negative 4, 3. Label that D. All right, so looking at this, thought there was a way to connect the lines. You can use slope to determine that these are parallel, then these are parallel as well. And then these slopes should be the negative reciprocals of each other. So rise over run, we're going to go down 1, 2 over 1. So that would give me a negative 2. For this one, rise over run, we would go up 1 over 2, giving me a positive 1/2. So negative 2 and positive 1/2, those are negative reciprocals, making this a 90-degree angle. And then we would do the same thing to this side and this side. All these two are all right angles, and that makes this a square. That's it.